Traditional automation systems have always seen the PC, PLC and the RTUs as the central part of the system. However, today's connected world and the fourth industrial revolution demand the network to become the backbone for better delivery of value and savings to end users. OPC UA has addressed the interoperability challenges at the higher layers. However, when it comes to the field level and at the sensor level, there have been up to 30 different networks designed by different companies from different parts of the world. They are in wide use today and they create a number of information islands. Just like we use English language as a common medium of communication, we need a common network. Choosing one of the 30 options available today is going to be an advantage for few and a disadvantage for many. Inventing a new network is also not an option unless it offers something significantly new, as people will always have an inertia to switch. This is where TSN or time-sensitive networking comes into picture. After the 1990s, Ethernet and TCP/IP became the de facto standard for communication in the office network. But unfortunately, they had their shortcomings when it came to the machine world. Machines expected deterministic communication and TCP/IP and Ethernet by design could not do that. Every attempt made by the companies in the machine world to address this challenge in a standard manner resulted in creation of a new so-called standard, complicating the very issue they tried to address. Something big had to happen and help came from an unrelated market, the audio-video broadcasting industry. Ethernet technology was invented by Xerox in the 1970s and it was maintained by IEEE under two standards, 802.1 and 802.3 from the 1980s. Traditionally, audio-video broadcasters were using analog point-to-point cables for designing live concerts. They felt that it was rather complicated and expensive. In 2009, they began exploring ways to simplify streaming through the use of Ethernet cable. They started an initiative to upgrade the Ethernet standard as they wanted time-bound delivery of packets for high-quality audio and video transmission. Automotive and industrial groups saw that they had similar use cases and joined this project in 2012, and the working group name for this project was changed from audio-video broadcasting to time-sensitive networking. Today, everyone sees OPC UA including TSN as the only way for machines to talk to each other and talk to cloud. This is a major breakthrough for innovation and this will change the way technologies like digital twin, blockchain, AI and AR will impact our lives. In the future, apart from smart factories, TSN and 5G will also enable use cases like driverless cars, drone deliveries, smart utilities, smart buildings and smart supply chain management.